Hello, this is Dr. Ryan Johnson, and this is the course Introduction to Statistics. Today we're doing section 10.2, which is comparing multiple means, the theory-based approach, which basically means we're talking about ANOVA. So, you should have read through 10.1 and 10.2 in the Zybook, and so now we're here, and we should have gotten to the different ways of defining F, the broad way it's defined, and then more detailed way a little bit further in. That's kind of a more detailed way of finding it, and some different formulas there. We'll kind of talk about how to do that in a spreadsheet instead of an ugly formula. So in our worksheet here, the study is looking at several different diets that were very popular in the mid 2000s. So we've got, let's see, study, there's the Atkins diet, which is very low carb, the Zone diet, which is like 40-30-30 ratio of carbs, protein, fat, the Learn diet, which is high carbohydrate, low fat, and the Ornish diet, which is low fat. So they randomly assigned women aged 25 to 50 with body mass index of 27 to 40 to one of the four diets. The 311 women who volunteered to the program were educated on their assigned diet and were observed periodically as they stayed on the diet for a year. At the end of the year, they calculated the change in BMI for each woman and compared the results across the four diets. Okay, so for our first question, what is the overarching research question the researchers hope to answer? Okay, so use your common sense knowledge of the world there. Make it a precise question that can be answered by numbers, by statistics. Okay, then for number 2, part A, what are the observational units in the study? So that should be the things that we counted up for our sample. And identify the explanatory and response variables. Classify them as categorical or quantitative, and it goes on from there. So again, that's pretty much review, so let's move on. Number 3, does the study make use of random sampling, random assignment, both or neither? What are the implications of your answer with regard to scope or inference? So this is review of chapter 5 material here, being able to use your common sense knowledge of the world as you look at the study. Did the researchers collect the data as paired data or independent samples? In other words, according to the study design, are the responses from one treatment group paired with or independent of the responses from other treatment groups? So this is review from, chapter 7 that we did, paired design? Yeah, so that's review as well. So we'll move on to number 4. State the null and alternative hypothesis, both in words and symbols, for testing the research conjecture. Now here, this is the first time you're doing a null and alternative hypothesis for an ANOVA situation, but you should match the way that a null and alternative hypothesis were made in the Zybook. Okay, so the null hypothesis back in the Zybook was like all three groups long run means are about the same. Alternative hypothesis, at least one of the long runs is different. Now notice that there is no equation for the alternative, because writing down that as equation is actually really messy. It's actually much simpler to say in words. So same applies for your answers to this worksheet. No need to write down the complicated equation if the Zybook is not doing it. Okay, step 3, explore the data. The data for this investigation is in a file called diets. Yeah, there's a link there. Copy and paste the data into the multiple means applet. I have good news for you, and that good news is that that data is already in the multiple means applet. So if we go to our Canvas page, we click on applets, that will take us here. We click on multiple means, and that will take us here. And if we select data and go to diets and then use data, we have, it even has a description of from the beginning of the worksheet. I'm going to close that though. Okay, so report the mean and standard deviation of the BMI samples in this sample. So then you should be able to, just copy those things. Check the show groups box. and then we've got there. Now from here on out, I'm going to delete some of my data so that I have different numbers than you. Delete some Atkins, delete some zone, maybe delete some Ornish, and use this data. Okay, so now my numbers are different from yours, but all the process is the same. All right. So I clicked the show groups. You can check the box plots overlay of these as well. Report the means, standard deviations, and sample sizes for the change in BMI for each diet. So for each diet, you're looking at this table down here of the sample size is N, the mean, the standard deviation. Describe what the graphs and statistics reveal about whether the diets appear to differ with regard to change in BMI amounts, and if so, which diet appears to be best and which worse. So this is just an intuitive looking at the graphs, okay? So, if you just intuitively notice Atkins has a lower mean, so it looks lower, the mean is lower, but it's also more spread out. So say something like that. Use your common sense and knowledge of the world. Use full sentences there. Okay, number 6. Conduct a simulation-based randomization test as we've done in the last section. Compare the 4 groups. So I'm going to show you how to do this. It's kind of the same as all the other ways, but we never did it for multiple means. So here we go. So click the shuffle options. Okay, so we were doing mean group diff, so as they ask. We'll do my computer can handle 10,000. If yours can only handle 1,000, then go with that. So we'll shuffle. It takes a little time if you do 10,000, but there we go. And then you take your observed mean and you copy it, and then you paste it over here. You count, and you want to count to the right because this is a number similar to chi-squared where there is no negative numbers, only positive numbers. So conduct a simulation, then determine and report a p-value based on, so if I change the numbers, but my p-value is 0.0233. Yours will be different, okay? So then based on this p-value, evaluate the strength of evidence against a null hypothesis provided by the experimental data. In other words, do the data provide strong evidence? So my data is different from yours slightly, but given that p-value, I would say there's strong evidence in favor of the hypothesis that some of the diets are different than others. That's our hypothesis. You have to go back to what our hypothesis is. Okay? We haven't proved this is not the number that says Atkins is better than the others. This just says one of them is different from the others. Okay, so although the mean group diff is fairly easy to understand and calculate, it's not commonly used, in part because there's no theory-based model for the null distribution. Another downside is that the mean group diff is not standardized, so it's not comparable across studies. Okay, so instead of comparing only the difference in means, a statistic could standardize those differences by comparing to the amount of within group or natural variability to the response variable while also taking sample size into account. So that's what we want. And the thing that we're going to get then is called the F statistic. So it's more commonly used, it's a theory-based way to do it. So it's going to equal 0 when the groups all have identical means. Otherwise, it'll be positive with larger values indicating larger differences. So the main idea is you're going to do between group variability, which is the zone formula, divided by within group variability, which is its own formula. But we're just trying to get you an intuitive idea of what the F statistic is. Okay, so pull down the F statistic. Okay, now I need to have a different number because I have a different F statistic. So I'm going to copy that. Remember that my number is different from yours. Copy and paste. All right, so, and remember to keep it at greater than because the F statistic does not go negative. So to be more and more different would only be more positive. Okay, report the observed value of the F statistic. So I would report that my F statistic is 3.079, and then use the simulation results and observed values F statistic to estimate the p-value. So my p-value is estimated at 0.233, 7.3 is the p-value similar to 1 based on mean group diff. Mine was. Maybe yours will be too. Who knows? All right. Now, we're at number 9. Okay. So this guy right here is the F distribution. So if we overlay the F distribution, look at how nicely that follows that. Okay. Would you say there's good agreement between this theoretical prediction and your simulated null distribution? For me, yes. How does the theory-based p-value compare to the one you found from simulation? 0.0273 and 0.0282 is get out of here. Is basically the same. Okay, so that's how it compares. Okay. Confirm the F statistic is the ratio of the mean squared for treatment to the mean square for error. These are the numbers in the MS column of the ANOVA table. So to confirm that, you need to go over here and F statistic, show ANOVA table, and you need to just take this number divided by this number, and if you get this number, then write that down and put a check mark next to it. That's how you verify. Okay, now that's going to end this portion of the this first part of the video, and I'll start the next video in a second.